morning, everybody. Myself, Mr. Sri Ganesh V. Gaikwad, Associate Professor, Department of Chemistry, Dayanand College of Arts and Science, Solapur. Today we are going to discuss about the phase equilibria. Now, before going to discuss the phase equilibria, you must know some terms which are involved in these topics. So first term is system. System, it is a part of universe which is under observations. In this part, the change in temperature, pressure or concentrations can be carried out to study the effect of such changes on equilibrium. So there are two types of systems. One is the homogeneous system, another one is the heterogeneous system. Now let me try to discuss one by one. The homogeneous system is the system in which all the reactants and products are present in one phase. So the system in which all the reactants and products are present in one phase is called as homogeneous system. For an example, so hydrolysis of methyl acetate. So if you look the hydrolysis of methyl acetate, we come to know that the product of this hydrolysis is acetic acid and methanol. So in these reactions, all the reactants and products are present in one phase. So methyl acetate is present in a liquid state, water is also present in a liquid state, acetic acid is also present in a liquid state, and at the same time methanol is also present in a liquid state. So in this example, all the reactants and products are present in only one phase, so that the system is homogeneous system. Now define heterogeneous system. So heterogeneous system, the system in which the reactants and products are present in more than one phase is called as heterogeneous system. So look, the decomposition of calcium carbonate. So calcium carbonate decomposes into calcium oxide and carbon dioxide. So calcium carbonate is in a solid state. Calcium oxide is also in a solid state, but CO2 is present in a gaseous state. So in these reactions, calcium carbonate is the reactants and calcium oxide and carbon dioxide are in a solid and gaseous state respectively. So in this example, the system having reactants and products in a different phases, so that it is the heterogeneous system. So it is possible to study the different homogeneous reactions by the application of law of mass action. However, the heterogeneous reaction, it is difficult to apply the law of mass action because so many limitations involving. Thus, the effect of change of temperature, pressure or concentrations on heterogeneous system in the equilibrium can be well studied by the application of phase rule. So this relationship governing all heterogeneous equilibria was first discovered in 1975 by an American physicist, Willard Gibbs. Hence, rule is known as Gibbs phase rule. Mathematically, this Gibbs phase rule can be stated as F is equal to C minus P plus 2, where in this equation F is the number of degree of freedom, C is the number of components, and P is the number of phases of the system. The term phase, components and the degree of freedom involving in the statement of the phase rule have specific significance. Now let me try to know about the phase, about the components, about the degree of freedoms one by one. So now we know that Gibbs phase rule is F is equal to C minus P plus 2. Now in the equation, P stands for the number of phases, F stands for the degree of freedom, C stands for the number of components. So now let me try to define the phase. A phase may be defined as it is a homogeneous, physically distinct, mechanically separable part of the system. To be physically distinct, phase would have a definite boundary. And the term mechanically separable means each term can be separated from the every other phase by simple process like filtration, decantation, or using separating funnel. So this is all about the phase. Now let me try to discuss with the help of examples. So a system may consist of one phase or more than one phase. For an example, a system containing liquid water. So a system containing only liquid water is having only one phase, that is P is equal to 1. But a system containing liquid water and vapor, water vapor, so this system is having two phases, that is P is equal to 2. Or a system containing liquid water, water vapor and solid ice, so this system is having the P is equal to 3. The number of phases for this system is 3. So when water is equilibrium with water vapor, which is equilibrium with ice, the system is having 3 phases. But only water is there, so system having only one phase. So in this way we can define the phase and we can calculate the number of phases present in a particular system. A system containing one phase only is called as homogeneous system. System containing two or more than phases is called as heterogeneous system. Ordinarily, 3 states of matters, gas, liquid, solid, are known as the phases. So examples to understand the meaning of the term phase. Now suppose that a pure substance is there. Now all of you know that a pure substance may be present in a solid state, may be present in a liquid state, or may be present in a gaseous state, made up of one chemical species only and is considered as one phase. Thus oxygen, O2, or benzene, C6H6, and ice, water, are all one phase systems. It must be remembered that a phase may or may not be continuous. Thus, whether ice is present in a one block or many pieces, it is considered as one phase only. Now, second example, mixture of gases. All of you know that all gases mix freely to form homogeneous mixtures. Therefore, any mixture of gases, say O2 and nitrogen, is one phase system. Or suppose that a mixture of gas having 5 different gases. So this is also having only one phase. Or suppose that miscible liquids are there. So two completely miscible liquids yields a uniform solution. Thus, a solution of ethanol and water is one phase system. So when miscible liquids are there, all miscible liquids are having only one phase. But non-miscible liquids are there. A mixture of two non-miscible liquids on standing forms two separate layers. Hence, mixture of water and carbon tetrachloride constitutes two-phase system. Or in fifth example, say that aqueous solutions. So an aqueous solutions of solid substance like sodium chloride or sugar is uniform throughout. Therefore, it is a one-phase system. However, a saturated solution of sodium chloride in contact with excess solid sodium chloride is a two-phase system. Or suppose that mixture of a solid. A mixture of two or more chemical substances contains many phases. For an example, a mixture of calcium carbonate and calcium oxide having two phases, both are solid. Decomposition of calcium carbonate having three phases, two solid and one gaseous. NaCl crystal along with copper sulfate crystal, two phases, both are solids. So in this way, we can define or we can distinguish the phases from the system. So now let me try to discuss about the components. In phase rule equation, C stands for the number of components. The symbol C in a phase rule equation stands for the number of components of a system in equilibrium. The term component may be defined as the number of components chemically independent species by means of which the composition of every phase can be expressed either directly or by chemical equations. Zero or negative quantities of components are allowed. For an example, suppose that the water system and sulfur system. So the simplest example of water system where ice equilibrium with water vapor. Here in this example, all the three phases can be expressed in terms of one chemical individual, that is H2O. Hence, water system has one component. Similarly, in sulfur system, all four phases, that is rhombic sulfur, monoclinic sulfur, vapor sulfur and liquid sulfur, are expressed by means of single chemical individual S. Hence, it is a one component system. Say another example, mixture of gases. Suppose that a mixture of nitrogen and oxygen is there. So in this example, in this system, only one phase is there. So all of you now know that all gases, a mixture of gases having only one phase. But to express the system, that is a mixture of gas containing oxygen and nitrogens, so this is the two component system, because to express this system, we have to use the two chemical individuals O2 as well as N2, so that it is having component 2 but having phase 1. Hence the mixture of oxygen and nitrogen has two components and one phase. Similarly, in the example sodium chloride solutions, a solution of sodium chloride in water is a one phase system, but its composition is expressed in terms of two chemical individuals, say NaCl and H2O, so that the sodium chloride solution is a two component systems. So therefore, an aqueous solutions of NaCl or any other solute is a two component system. Or in another example, that is saturated solution of sodium chloride in contact with excess of solid sodium chloride has two phases, namely aqueous solutions and sodium chloride. The composition of both the phases can expressed in terms of two chemical individuals, NaCl and H2O. So it is a two component system. So again, in the example of decomposition of calcium carbonate, when calcium carbonate is heating in a closed vessel, the equilibrium of a system is calcium carbonate is equilibrium with calcium oxide and CO2 gas. So it has a three phases, two solids and one gaseous. The composition of all phases can be expressed in terms of any two of the three chemical substances in equilibrium, so that it is having two components. Suppose that if you select the calcium oxide and calcium carbonate, suppose that if you select the calcium oxide and CO2 as the components, then we can write the three possibilities as calcium oxide gives calcium oxide plus 0 into CO2. Second, CO2 gives CO2 plus 0 CaO. Calcium carbonate gives calcium oxide plus CO2. Say in this way, to show the decomposition of calcium carbonate, we can select the two formulas out of these three to express the decomposition of calcium carbonate. Hence, calcium carbonate, a system decomposition of calcium carbonate is the two component system and having three phases. Okay, let me stop here. Thank you.